On most Evolution Harley-Davidsons, the ignition timing is controlled by an ignition control module, or ICM, and the ICM is programmed with two spark control curves. One curve has more advance and one curve has less. The ICM is controlled by a vacuum-operated electric switch right here, which is activated by intake manifold vacuum, which essentially ranges from about 20 inches of mercury vacuum to all the way down to 0. The switch basically has two leads coming out of it and also a vacuum connection to the intake manifold. And the operation of the switch is really simple. When intake vacuum reaches a certain threshold, the switch closes and current flows through the switch from one lead to another. This particular lead is grounded, and this particular lead, both the leads are black by the way, and this particular lead is connected to the ignition control module. On the newer versions of the VOES, you essentially have a single connector, which is a Deutsch connector, and just two pins, but the basic operation is exactly the same. So a good way to test the vacuum-operated electric switch is by using a vacuum pump and an ohm meter. So what we're going to do is actually simulate the conditions that the switch sees in the intake manifold and apply vacuum to the switch, and at a certain point the switch is going to close. So when vacuum in the intake manifold is high, the switch is closed and current flows, and when vacuum in the intake manifold is low, the switch is open and current does not flow. High vacuum conditions are generally associated with idle or steady-state cruise at relatively low RPM, and low vacuum conditions are associated with wide open throttle or high load conditions when the motorcycle is in high gear, for example, going up a grade. So different bikes have different set points for the VOES. For example, this is a Dyna, but the same is true for FXRs, Sportsters, and Softails. The switch turns on and is grounded and grounds the grounds the ignition control module at about 4 inches of mercury, anywhere between 3.5 and 4.5. On heavier bikes, such as FLTs, for example, the switch closes between 5 and 6 inches of mercury, and so this is for late Evos. On the earlier Evo FLTs, the threshold is higher, and that's around 7 inches of mercury. So let's test the switch and see whether it's operating correctly. So what I'm doing is I'm activating very slowly the vacuum pump right before we hit 5 inches of mercury right there. The switch should close, and as you can, if you look at the ohm meter, right now the circuit is open. We have an open circuit, and when the switch closes, we're actually going to hopefully see continuity. Resistance technically is supposed to be 0 ohms, but that's never the case. It's probably going to be something on the order of 10, 20, or 30 ohms. So let's see what happens as we activate the vacuum pump. So again, you have to do it very slowly. One thing that you will be able to hear is a very, very soft click from the switch when it gets to the switching point, which in this case is going to be about 4 or 4.5 inches of mercury. It's difficult to hear, but you can if you really try. So you can see that the switch activated at around 4.5 inches of mercury, and you could hear the tiny click. And what I'm going to do now, if you look at the dial, I'm going to go all the way up to about 20 inches of mercury, which is kind of the outer range of vacuum that the switch sees. And so you can see that right now we're showing somewhere around 13 ohms. So I'm just going to keep going. Once the switch closes, there shouldn't really be a problem, but I just want to test it and see if it can take 20 inches of mercury. Perhaps there's some problem with the diaphragm that it'll show, but I don't think that's going to be the case. So I'm getting to about 20 inches of mercury. We still have continuity. There's about 12 ohms of resistance, so that looks good. When I deactivate the pump, vacuum is now 0 and the switch is open. As I mentioned, for Dynas, Sportsters, and FXRs, and Softails, the range is from 3.5 to 4.5. And it's good to keep in mind that the higher vacuum set point means that the ICM switches to spark control curve with less advanced sooner, right, which kind of protects the motorcycle, especially if the motorcycle is hopped up, so it won't ping as much. And lower vacuum set points mean that the ICM switches to spark control curve with less advanced later. This particular guy switches at 4.5, which is kind of on the safer side, so I'm going to leave it here. And you might ask, well, how do you adjust it if you wanted to? If you look right there, on the VOES, you can see that kind of this nose cone has some sealant there. And if you remove that sealant, there's an adjustment screw that can be used to adjust the set point of the switch. And for example, if you want the switch to switch at a higher vacuum reading, you would remove the sealant completely to expose the adjustment screw. And then if you turn it clockwise, then the switch is going to switch to the spark control curve with less advanced sooner. And if you turn it counterclockwise, it would be the opposite. So you really don't want to turn the screw any more than about 2 turns in, because you might damage the diaphragm that's behind the screw. Maybe even 1.5 turns would be a safe number. Probably a 1/8 or a 1/4 turn at a time is a good number of turns. Keep in mind that when you're testing your adjustment, if you have removed the sealant, you're going to have to somehow seal that opening now. And so either you put your finger over it, or maybe put some really sticky tape over the opening so you can actually test the operation of the switch. And when you are done, you're going to have to reseal it with silicone. Make sure that there's just enough sealant to, again, the point is not to have the sealant be in contact with the adjustment screw. The point is only to seal off the nose, right? So you just put just enough sealant there to seal it off. Make sure that the sealant doesn't penetrate any further than it needs to. It just seals that opening. And as I mentioned before, the lighter bikes, like the Sportsters, Dynas, and FXRs, have the set point of the VOES at about 4 inches of mercury, anywhere between 3.5 and 4.5. And then the heavier bikes use a higher vacuum setting, and that's because the engines of the heavier bikes are under much greater load simply because of the weight of the motorcycles, right? So you want to be on the safe side and use the higher vacuum set point, which means that the spark control curve with less advance is going to be used sooner on the heavier bikes than on the lighter bikes. And also, for example, if you're modifying your motorcycle and it has higher compression, you may have to adjust your VOES to use the higher vacuum set point, again, so that the curve with less advance is used sooner to protect your engine.